We are solving question number 45 from GATE 2013 Chemical Engineering paper. The question is related to the subject of process control and instrumentation. A control valve with a turn down ratio of 50 follows equal percentage characteristics. The flow rate of a liquid through the valve at 40% stamp position is 1 meter cube per hour. What will be the flow rate in meter cube per hour at 50% stamp position if the pressure drop across the valve remains unchanged? Answer up to two digits. So first of all, in the given question, we have been provided an equal percentage characteristic valve. So this means that the flow characteristics of the valve will be governed by the equation F is equal to F naught e raised to beta x, where F we define it as the flow at this valve opening of x upon the maximum flow possible through the valve, that is Q upon Q max. Similarly, F naught we can write it as this initial flow upon the maximum flow will remain same, e raised to beta x. So that is, we can, in terms of the flow rate through the valve, we can write this as Q is equal to Q naught e raised to beta x. The other thing we have been given is a turn down ratio of 50. Let us denote this turn down ratio by T, and it is given as 50. So turn down ratio is defined as the ratio of the maximum flow possible through the valve upon the minimum flow, that is Q max upon Q minimum. So this maximum flow will occur when the valve is 100% open. That means when x is equal to 1. Similarly, the minimum flow will occur when the valve is 100% closed, that is, it is fully closed, that is x equal to 0. So we can replace the value of x in this equation and put and find the value of the constant beta using that. So we will be putting, for finding the maximum flow, let us put x equal to 1 in this equation. So it will become Q naught e raised to beta 1. And for x equal to 0, it will become e raised to beta raised to 0. So that is, this 50 will be equal to e raised to beta. This will be equal to 1. So the value of beta can be found out by taking the natural log on both the sides. So that will be beta is equal to ln of 50. This will come around 3.912. Now we have been given these two different scenarios, that is the flow rate of the liquid through the valve at 40% stamp position is 1 meter cube per hour. That is, let us consider it as case 1. So Q1 is equal to 1 meter cube per hour at x equal to 0.4. And for case 2, Q2 we have to find, and the valve opening is, the stamp position is 50%, that is at x equal to 0.5. And we found that beta was 3.912. Now we can straight away use this relation, Q is equal to Q naught e raised to beta x. Now using the information from case 2 and case 1, we can write this as Q2 upon Q1 is equal to Q naught e raised to beta x2 upon Q naught e raised to beta x1. So this will get cancelled out, and we will be having Q2 is equal to Q1 e raised to beta x2 minus x1. So Q1 we have been given as 1 into e raised to 3.912 x2 is 0.5 and x1 is 0.4, that is x2 minus x1 will be 0.5 minus 0.4, that is 0.1. So q2 will be equal to e raised to 0.3912. So you can calculate this and it will come around 1.478. So the flow rate when the valve opening is 50%, it will be 1.478 meter cube per hour. So the final answer, that is up to 2 digits, we will report it as 1.48.